An operator is faced with a greater challenge when the unit is operating abnormally. There may be several different reasons for abnormal operations, so an operator must develop troubleshooting skills to identify and solve these types of problems. The feed is usually preheated in a furnace or heat exchanger so that it will thoroughly vaporize when it's mixed with the catalyst. There are a number of problems that can cause a reduction or loss of the feed preheat. These include a failure in the instrumentation system, a cutoff of the fuel or steam supply, ruptured or foul tubes in the furnace or heat exchanger, and water in the feed. When the feed preheat is reduced or lost, there may not be enough heat to vaporize the oil in the riser. If this occurs, a mixture of liquid hydrocarbon and catalyst may muddy up the riser and force the unit to be shut down and cleaned out. Another abnormal situation is afterburning in the regenerator. Air is added to the regenerator to burn coke off the catalyst, but if too much air is available, the flue gas may also combust. This uncontrolled burning of flue gas is called afterburning. The primary symptoms of afterburning are a sudden increase in regenerator temperature and pressure. These high temperatures can damage the catalyst, the cyclones, and other metal hardware inside the regenerator. A feed or charge pump is responsible for moving oil into the unit. A loss of power or a mechanical problem may cause this pump to fail. If the feed pump fails, the flow of oil to the unit will stop, and without oil vapors flowing up the riser, the catalyst will not be able to circulate properly. As a result, the reactor temperature, pressure, and catalyst level will rapidly decrease. Obviously, normal operation of the unit cannot continue without a source of feed. An air blower provides combustion air to the regenerator. A failure of this component may be caused by a mechanical problem or a loss of steam or electrical power. If the air blower fails, it will not be possible to burn carbon off the catalyst, so there will be a sudden decrease in the regenerator temperature and pressure. This will reduce the differential pressure across the regenerated catalyst valve. Since the oil cannot be cracked with a spent catalyst, the unit will have to be shut down unless the situation is corrected. Another condition that will cause the unit to operate abnormally is a failure of one of the valves that control the flow of flue gas, spent catalyst, or regenerated catalyst. A valve failure can result from problems in the instrumentation system, such as a controller malfunction or a loss of hydraulic fluid pressure, or the valve may fail because of mechanical problems within the valve itself. The flue gas valve controls the regenerator pressure by regulating the flow of flue gas out of this vessel. If this valve fails, the regenerator pressure may change suddenly. This could result in a loss of differential pressure across the regenerated catalyst valve or the spent catalyst valve and lead to a flow reversal. An equally serious situation will occur if either the spent catalyst valve or the regenerated catalyst valve fails. A failure in one of these valves throws the whole system out of balance. The problem must be immediately corrected to prevent a major upset and possible flow reversal. Gases in the fractionator and the reactor are removed by a gas compressor. A loss of power or a mechanical problem can cause the compressor to lose some or all of its capacity to compress gases. If this happens, there will be a sudden increase in fractionator and reactor pressures. This interferes with fractionating efficiency and limits the amount of feed that can be processed through the cat cracker. It also changes the differential pressure that exists across the spent and regenerated catalyst valves. Another situation that will cause a major upset is a loss of power. A power loss is usually due to problems outside an operator's control, such as an accident, lightning, or a short at a junction box. In the event of a power failure, electrically driven pumps, compressors, instruments, and valves will fail. Unless a backup power system is available, a loss of power means that the unit must be shut down. Problems in the fractionator can also cause a cat-cracking unit to operate abnormally. For example, if a fractionator becomes flooded with liquid hydrocarbons, there will be pressure surges inside this vessel. These pressure surges will back up into the reactor and cause it to operate erratically. Sometimes the outlets at the bottom of a fractionator will become plugged with coke deposits. If this happens, product cannot be drawn from the tower, so the unit must be shut down and the deposits cleaned out.